Hello everyone, Merry Spring Festival. Let's continue. So, why doesn't a less attractive woman or a smaller bust trigger the scholar's chest-related G group to activate intensely? To answer this, we first need to understand the concept of the feature inner structure of sensory G waves. What is the feature inner structure? It refers to the key segment within a G-wave that defines its uniqueness, which we will call the feature inner construct. When the scholar walks and thinks, encountering a telephone pole triggers him to avoid it, and encountering a bust woman causes him to glance. Why are the reactions different? Even though both are sensory G waves, it's because the feature inner constructs of these G waves are different. We know that the mental representation of the telephone pole and the large breasts exist in different parts of the brain, even though both are processed in the visual G wave processing regions. These two representations are distinct. One is related to the telephone pole and the other to the breasts. When a sensory wave, G wave, related to an object enters the brain and passes through the G wave display area, we perceive the object. The G wave continues to project and activate the image representation of that object, which in turn activates other aspects of the object. Objects do and creates forces that guide corresponding actions. Thus, when the scholar sees a telephone pole or large breasts, the difference in their reactions is because the two sensory G waves have distinct feature inner structures. Remember from chapter 8 when we used the example of a baby's cloth duck. We discussed fuzzy recognition and objection recognition. Clearly, fuzzy recognition happens because the feature inner constructs of the G waves are similar, while object recognition occurs when the G waves have significantly different feature inner constructs. Now, the feature inner construct is not only present in visual G waves, it exists in all sensory G waves. For example, a distinct accent, a familiar touch, or a comforting taste all carry their own feature inner constructs. So how do these feature inner constructs in G waves get recognized? Let's continue with the example of visual G waves. First, let's look at how an image representation of an object is formed. For example, how does the scholar's image representation of a telephone pole form? In most cases, it's created through the input of visual G waves related to the telephone pole. This means that the feature inner construct related to the telephone pole is involved in the creation of the image representation. If the scholar recognizes something as a telephone pole, the feature inner construct of the visual G wave activates the corresponding image representation of the telephone pole. We can think of the feature inner construct like a key, and the image representation like multiple similar keys that leave the same imprint on soup. As long as the new key fits the imprint, fuzzy recognition is triggered, and the image representation is activated when an object's feature inner construct perfectly matches the image representation in the brain. The image representation is strongly activated, and the imprint becomes clearer, stabilizing the representation. When we encounter a new object, we don't know exactly what it is, but the brain might think it resembles something else. This is because the sensory G wave containing the feature inner construct is dispersed or reprojected and activates multiple image representations. When faced with a more complex object, the sensory G waves feature inner construct may have several elements. For example, when we are appreciating the opposite sex, our brain slightly activates the G group related to aesthetic appreciation. This activation affects the subsequent direction in which the visual G wave is projected in the G wave display area. When you assessing the ability of the opposite sex, every part of their face, their body, and even their voice and behavior might catch your attention. This is because when you aesthetic appreciation G group formed, it involved the feature inner constructs of those parts. If every part of the object you are appreciating perfectly match the corresponding aesthetic appreciation G, then the sub-G waves of this G group will be strongly activated, and the overall G wave will become strong enough to dominate the focus area. We have introduced the concept of the overall G wave here, using the combinability and multiplicity of G waves. We can view the chest-related G group as a larger combined G, and this overall G wave will dominate the focus area. So, what behavior does this lead to? That depends on the vector computation effect between the overall G wave and other G waves present at the moment. Now, back to our original question. Why doesn't a less attractive woman or a woman with a smaller bust strongly activate the scholar's chest related G group? This reason is that the features of facial beauty G and breast related G are subGs of the scholar's chest related G group. When the woman is not attractive or has a smaller bust, these subGs do not activate strongly, meaning the scholar's overall chest related G wave is not strong enough to win the vector competition. Therefore, the scholar does not continue to look at the woman's breasts after glancing at them. The reason why the subgroups don't activate strongly, thus the overall G wave isn't strong, is something we'll discuss in more detail later. So that's all the content today. See you next time. Bye bye.